Okay, this is a pretty crazy derivative, but they start mentioning logarithms, and they're kind of giving away what we need to do. Take a logarithm of both sides, because the power property of logarithms will make this simpler, make it something we can even work with. Right now it's just crazy. Okay, so we're taking a natural log of both sides. So what that does for us on the right side is it lets that 5 square roots of x come down and multiply. And notice we haven't done calc yet, right? This is pre-calc stuff when we deal with logarithms. Now if we try to take a derivative of both sides, here, I'm not going to write it again, but taking the derivative with respect to x of both sides, when you evaluate this derivative with respect to x, we're going to need implicit differentiation, right? It's 1 over y. That's the derivative of the outermost function, the derivative of the natural log. And then times the derivative of the innermost function. It's dy dx, which this is the thing we're trying to solve for. And over here, if we take the derivative with respect to x, this one needs the product rule because it's 2 different functions of x being multiplied. So it's the derivative of the first function. So the power rule means the 1/2 comes down, then it gets reduced by 1, so it goes from 1/2 to negative 1/2. With the second function kept the same, plus the original first function times the derivative of the second function. So this is going to be 1 over 5x times 5 because of the chain rule. That's the derivative of the second function there. So before we try to get that y taken care of, we can do a little simplifying. We can do 5 over 2 square roots of x, natural log 5x. And then here, I don't know, we got 5 times, oh wait, these 5s are going to cancel though. So you got 5 square roots of x over x. We can simplify that. You can just say there's a square root of x in the denominator, because this is a 1/2 power divided by something to the first power. The power is subtract to make x to the negative 1/2. So it'd be easier to write it as this. I was hoping those would combine, but they don't. Actually, either way, I don't know. This one doesn't have a radical in the denominator, so I kind of like this form better. I'll check and see what Newton wants after. But I just need to multiply that y to both sides, and now we have our derivative. And if you wanted to express this derivative in terms of just x, well, we know what y is in terms of just x. You can just replace this y with 5x to the 5th root of x power. So let's do that. 5x to the 5th root of x. And then looks like there's... Here, let's put that back as this form. Same thing. Because you can factor out a 5 over the square root of x times everything. If you do that, you've got natural log 5x over, we factored that out, so that's a 2 plus 5. So that kind of looks nicer. I don't think there's anything left to combine. I think that's it. 5x, that's terrible writing. 5x to the 5th root of x times 5 over the square root of x times this.